doing systems of linear inequalities. So system of linear inequalities. Oh look, they have a puzzle for you. So a system of linear inequalities is what?
Made up of two or more linear inequalities.
It's made up of two
or more linear inequalities.
Very good, very good. And then a solution of a system of linear inequalities
is an ordered pair that makes all the inequalities in the system true.
Wow, you guys are good at puzzles.
Smart.
All the inequalities in the system true. Very good. All right. So you can graph the solutions of a linear system, a system of linear inequalities in the coordinate plane. The graph of the system is the region where the graphs of the individual inequalities overlap. Okay, so that's important information right here. Okay, the graph of the system is the region where the graphs of the individual inequalities overlap. So where the inequalities intersect, where they overlap, that is where the solution is. Okay? So problem 1 is graphing a system of inequalities. So we want to know, what is the graph of the system? Now remember, when you're graphing, you want to have your inequality in slope-intercept form, so you can get the slope and you can get the y-intercept. So if you look at the first one, y is greater than or equal to negative x plus 5. That's already in slope-intercept form. So we can identify our slope and our y-intercept. I'll just do this one in blue. So for the first one, slope is equal to, well actually I'll just write it up there. So slope is equal to negative 1, and the y-intercept is equal to 5. Okay? So when we graph, we start at 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And the slope tells me to go, what?
Up, down,
Down 1 and to the right 1. So down 1 to the right 1. Down 1 to the right 1. Or I could go up 1
to the left.
to the left 1. Very good. Up 1 to the left 1. Now, here we have a greater than or equal to. Are we going to have a solid line or a dotted line? Very good. So our solid line looks just like that. And there's your graph. Now, it's a greater than, so is it going to be shaded above the line or below the line?
Above.
Above the line. So, there's the graph of your first equation. Then the second graph, we need to put it in slope-intercept form first, right? So we're going to add 3x on both sides. We end up with y is less than or equal to 3x minus 4. So here, my slope is equal to 3. My y-intercept is equal to negative 4. And now we graph. So we start at the y-intercept, 1, 2, 3, 4, down here. The slope tells me to go up 3 to the right 1. Up 3 to the right 1. Up 3 to the right 1. Okay? Again, we have a less than or equal to. Since we have an or equal to, it's going to be what kind of line? Very good. It's going to be a solid line. Don't forget to draw your arrows. Now, because it's a less than or equal to, are we going to shade above the line or below the line?
Below.
We're going to shade below the line. So, we shade below the line. Now the solution of this system of inequalities now is where you can see both types of lines. I have red and blue. You guys have some going in one direction, some going the other direction, right? So wherever you see the two types of lines, that is where the solution of the system of inequalities is. Problem 2 is writing a system of inequalities from a graph. Okay? So when we do this, we need to look at what kind of line there is, solid or dotted. We need to look for where it's shaded, above or below. We need to find slope, and we need to find y-intercept. And then we put it all together with our inequality. Okay? So, for the first one, let's do the first one. Let's do the blue. Okay, let's do the blue line. So for the blue line, this is shaded below. Does everybody see that? Shaded below. So since it's shaded below, it's going to be a less than. So it's going to be a y, and it's going to be a less than. Because it's a solid line, it's going to be a less than or equal to. Very good. Less than or equal to. Now we can look for our slope and our y-intercept. So our slope of this line, we're just going to pick 2 points on the line. Let's pick this one and this one. Okay? So the rise is up up 1 to the right 2. So my slope is what? 1/2. So the slope is 1/2. All right, so my slope is 1/2. The y-intercept, of course, is where it crosses the y-axis. So it crosses the y-axis right at 1. So the y-intercept here is equal to 1. So now we can put our equation together. So y is less than or equal to 1/2 x, good, plus 1. And there's our first equation. Okay? For the second one, do that in red. We want to, it's going to be a y. Now here we're shading below the line, so it's going to be a less than. It's a dotted line, so it's going to be just a less than. Okay? And now we can find our slope and our y-intercept. So for the slope, for the red line, we can choose, let's choose this point and this point. So we're going down 1 to the right 2. Down 1 to the right 2, the slope is -1/2. The y-intercept is where it crosses the y-axis. So here it crosses at 1. So the y-intercept is equal to 1. And now we're ready to put our equation together. So y is less than -1/2 x, perfect, plus 1. All right, problem 3 is using a system of inequalities. You want to build a fence for a rectangular dog run. You want the run to be at least 10 feet wide. The run can be at most 50 feet long. You have 126 feet of fencing. What is a graph showing the possible dimensions of the dog run? So the important information, we want the run to be at least 10 feet wide and at most 50 feet long. At least 10 feet wide and at most 50 feet long. You have 126 feet of fencing. All right, so we have a rectangular dog run. So what formula are we going to start with?
Perimeter.
We're going to start with the perimeter. Very good. So the formula for perimeter is 2 times the length plus 2 times the width. And this has to be 126?
Yes.
Or less. Very good. So it's got to be less than or equal to 126. We also know that we want the run to be at least 10 feet wide. So W at least 10 means 10 or more. It has to be greater than or equal to 10. And the run can be at most 50 feet long. So the length has to be at most 50 feet. So at most means less than or equal to, right? So the length has to be less than or equal to 50 feet. All right, so now when we're graphing this system of linear inequalities, we have 3 inequalities to graph. Because remember, when a system of linear inequalities is 2 or more, right? So we can go ahead and graph those two, the length and the width, but this one for the perimeter, we have to change to slope-intercept form first, right? Okay. All right, so now we want to put the first inequality into slope-intercept form. So we're going to subtract 2L on both sides. And we end up with 2W is less than or equal to negative 2L plus 126. Then we will divide by 2. So W is less than or equal to a negative L plus 63. Okay? So if I wanted to write this in, if I wanted to write this in slope-intercept form with the x's and the y's, let's say that this says y is less than or equal to a negative x plus 63. You see how we did that? Is that clear? Okay. All right, so now we have our inequalities that we're going to graph. The length is our x, and the width is our y. So when we put it on our graph, we have the length is the x, okay, and the width is the y. All right, so here's our graph. We have the length at x. We're counting by 5s. We have the width for the y's. And we're counting by 5s there also. And now we can put our graph on. So let's start with this one. Okay? We're starting at y is equal to 63, right? That's my y-intercept. So 63, this is 65, so 63 is about right there. Okay? And the slope tells me to go down 1 to the right 1. So rather than doing negative 1 over 1, I'm going to do negative 5 over 5. Okay? I could even do negative 10 over 10. Okay? But since we're right here, I'm going to go ahead and do negative 5 over, so negative 5 over 5. Negative 5 over 5. Negative 5 over 5. Does everybody see how this is going? Negative 5 over 5. And that's what your graph is going to look like. Okay? What kind of line are we going to have? Solid or dotted? Solid line. Very good. All right, so there's our solid line. And now we'll graph the y's greater than, I'm sorry. Where are we shading for this? Above or below? Very good. So we'll shade below the line. Right there. So let's do the next one in red. So y is greater than or equal to 10. So here is 10. It's a y equals. So we're right here. Y equals is a horizontal line. Let's make that one red. And this actually will go on forever in that direction, correct? Now, y is greater than or equal to 10. What am I shading, above or below? Above. So, there's the second graph. The third graph, let's do in green. Okay. X is less than or equal to 50. So that's an x equals, right? So there's my x equals at 50. All right, so here's the graph of x is less than or equal to 50, and where am I shading for this one? To the left, because it's less than, right? So we're shading, I'll shade like that. Where do all three graphs intersect? Blue, red, green, all in here, right? So in this triangle is where all of my solutions could be.